Bismillahirrahmanirrahim. Today, our topic of discussion is preparation of alkyne hydrocarbons. Dear students, you know that alkyne hydrocarbons are those hydrogen and carbon based organic compounds which contain at least carbon carbon triple bond. We will discuss in this session that how these hydrocarbons are prepared in the laboratory. There are three major processes by which you can prepare alkyne hydrocarbons. Number one is carbide process. Number two is dehydrohalogenation of dihalides. And number three is alkylation of terminal alkynes. So you can prepare alkyne hydrocarbons by three major processes. Now each process in detail. The first process on your screen is carbide process. This is the process in which the reactant is carbide. When you treat this calcium carbide with water, acetylene is obtained. This process is so efficient, you can use it on industrial scale. So reaction of carbide with water is represented like this. Calcium carbide, when it is treated with water, it gives you acetylene and calcium hydroxide. How this calcium carbide is obtained? When calcium oxide is treated with coke at 2000 degrees centigrade in the furnace, calcium carbide is obtained along with carbon monoxide. Similarly, you can also prepare acetylene by pyrolysis of methane at very high temperature that is produced by an electric arc. Methane, which is a natural gas, 80% of the natural gas is composed of methane. When when the pyrolysis of methane is carried out at high temperature, it is converted into acetylene and the hydrogen is the byproduct. Second very important process which is used to prepare alkyne hydrocarbon is known as dehydrohalogenation of dihalides. Dehydrohalogenation means that the process in which hydrogen and halogen are removed from the dihalide. So this process is very important. You need a strong base like potassium tertiary butoxide, sodamide, or potassium hydroxide for this type of process. You can use any type of dihalide, whether vicinal or geminal. A vicinal dihalide is that in which the two halogens are present on the adjacent carbon, whereas the geminal dihalide are those dihalides in which the two halogens are present on the same carbon. So mechanistically, you can say that it is the successive E2 elimination of hydrogen halide from dihalide. So the process can be represented like this. In a general form, this dihalide, when it is treated with two molecules of base, it is converted into carbon-carbon triple bond. Similarly, a geminal dihalide, this is an example of vicinal dihalide. Here is the geminal dihalide, it is converted into carbon-carbon triple bond. Here is the specific example of dihalide. Vicinal dihalide, when it is treated with potassium tertiary butoxide, a very strong base, it converts this dihalide into carbon-carbon triple bond containing alkyne hydrocarbon. This is alkyne hydrocarbon. Mechanism of this reaction. Mechanistically, this is E2 elimination. So it is elimination of hydrogen and halogen from the adjacent carbon. This is E2 elimination. When tertiary butoxide is treated with this halide, what happened? This potassium tertiary butoxide will furnish you butoxide anion. This anion will attack on this hydrogen. Elimination in first step leads to carbon-carbon double bond, and elimination in the second step leads to carbon-carbon triple bond. And the third very important method of preparation is dehydrohalogenation of a dihalide, not it is terminal alkyne, from terminal alkyne. When this terminal alkyne, you have to prepare this terminal alkyne, that is from the dehydrohalogenation of dihalide. You have to treat it with very strong base, that is soda amide in liquid ammonia. It will convert this into intermediate, which is susceptible to attack by this sodium amide to give you sodium acetylide. This sodium acetylide can be converted into terminal alkyne by using ammonium chloride salt. Here is the mechanism. Sodamide will furnish you this type of anion, will attack on this hydrogen. Hydrogen halide is eliminated in first step, in the second step, and it is converted into carbon-carbon triple bond containing this type of intermediate, where this hydrogen can be deprotonated by this type of anion, and acetylide is obtained. This acetylide can be converted into terminal alkyne by using ammonium chloride. So for the preparation of terminal alkyne, you have to modify this step. You have to modify, you have to use ammonium chloride. Third very important preparation of alkyne hydrocarbon method is alkylation of terminal alkyne. A variety of terminal alkyne can be prepared from terminal alkyne, a variety of alkyne hydrocarbons. This is not terminal. Alkyne hydrocarbons can be prepared from terminal alkyne. Preparation of acetylide and nucleophilic substitution. Here on screen, you can see the two steps which are used in the preparation of terminal alkyne. The first step is preparation of acetylide, and the second step is nucleophilic substitution. Here is the general representation. You can say that here is terminal alkyne. When it is treated with very strong base, it is converted into sodium acetylide because this hydrogen is acidic in nature and acetylide is obtained. When it is treated with ethyl bromide, it is converted into alkyne, alkylated carbon-carbon triple bond. So these were the methods to prepare alkyne hydrocarbons.